Hi everyone, welcome to the next video in the series. Last time we looked at a review of inverses and inverse concepts, and now we are going to continue to talk about inverses and also find their derivative. So I want to go back over composition functions one more time. So for instance, if I had f of x is equal to x squared, right, and I had g of x was equal to 2x, then if I wanted to find f of g of x, then I would start with the f function, and I would put the g of x on the inside. If I wanted to do g of f of x, right, you start with the g function and put the f of x function inside. So that's how that does that. Now the other thing about of composition functions is that a function, the composition function of a function and its inverse has to equal x, whether you do f of f inverse or f inverse of f. This means that the functions are inverses of each other. So if you had f of g of x, and then you wanted to put in, like, say, g of 1, right? So g of 1 is 4, then this whole thing here would be g of 1 would be 4, and then you would find f of 4. So we're going to be using that to find the derivative of inverse functions. And so we have to kind of keep in mind what we're saying. So if we say f of 0 equals 1, then f inverse of 1 equals 0. And I talked about that in the last video just briefly, and we're going to use it in this one. So Theorem 5.8 says continuity and differentiability of inverse functions. It says that let f be a function whose domain is in the interval I. If f has an inverse function, the following statements are true. If f is continuous on its domain, then f inverse is continuous in its domain. If f is increasing on its domain, then f inverse is increasing on its domain. If f is decreasing, then f inverse is also decreasing. And if f is differentiable on an interval containing c and f prime of c, and it does not equal 0, then f inverse is differentiable at f equals c, at f of c, sorry. All right, and then here, let f be a function that is differentiable on interval I. If f has an inverse function g, then g is differentiable at any x for which f prime of g of x does not equal 0. And g prime of x, the derivative of the inverse, that's what this says, is equal to 1 over the composition function f prime g of x. And remember that g of x is the inverse function. All right? And another thing to remember that's important is that the graphs of inverses have reciprocal slopes. So if one is 1/2, the other is 2. Okay? Okay, so here's an example of what we're doing. Our function is f of x equals x squared, and we want to find the derivative of f inverse of x at x equals 9. Okay, so what it's really asking here, it says when you're asked to find the derivative at a value of x, what they're really asking you for is the derivative of the inverse of the function at the value that corresponds to f of x equals 9. Because remember that if you're looking for this value, what this value is actually the y value of the function. So what we would do is we would set f of x, which is x squared, equal to 9, and then we would get two answers, plus or minus 3. And we could pick either. Generally, they'll just pick the positive one because you're trying to find not the derivative, but a derivative, and there could be more than one. So if I find x is 3, what I have found is that f of 3 is equal to 9, but f inverse of 9 is equal to 3. So I'm going to take the derivative of x, and I get 2x. And then in order to find the derivative of f inverse, I'm going to take 1 over the inverse, and then I'm going to evaluate it at x equals 3. So when I do that, I get 1 over 2 times 3, which is 1/6. So that would be the derivative of f inverse at x equals 9. That would be 1/6. So I would write that would be equal to f prime of x. Now you could come about this in a slightly different way. You could still be looking for f inverse of x, right? You could still be trying to find the derivative. Only this time, f of x equals x squared. That would be, if I go ahead and find the inverse, right? Just rewrite it with that. Switch x and y. And then y would be y inverse, that would be the inverse function, would be plus or minus the square root of x, right? So that f inverse of x would equal the square root of x. We'll pick one of those again, because it could be the derivative or it could be a derivative. All right, so if I find because what I'm trying to find is the derivative of the inverse, right? If this is g of x, what I'm looking for is g prime of x, the derivative. So, all right, so let's find the derivative of this. First, I'm going to rewrite it. This will be x to the 1/2. Well, the derivative of that, and that's why they call it g of x instead of f inverse of x, because it gets confusing here if you've got negative and then a prime and then da-da-da, right? So that's going to be 1/2 x to the negative 1/2, or in other words, 1 over 2 square root of x. And we remember from the previous screen that we said we were looking for that at x equals 9. So if you put x equals 9 in here, then you end up with 1 over 2 square root of 9, which is 1 over 2 times 3, which is, guess what? 1/6. So you can find it this way as well. Now we're going to use the formula, but I wanted you to see what we're finding here. If we find the inverse, we take the derivative of the inverse, we substitute the given value, we're going to get the same thing as we did on the previous screen. Okay, so on this one, here's another problem, an example pretty much like what you're going to find. G, if you'll remember that g of x is the same thing as f inverse. So g of x is going to be equal to the inverse function, can't get this to right, of x, right? That's what g of x is. So if g of 1 is 0, then find g prime of 1. G prime of 1. Okay, so the first thing that we want to do here, if we know that g of 1 is 0, then we know that f of 0 is 1. All right, so the first thing we want to do is take the derivative of the function, which is 2 minus sine x. Okay, and so then we're going to, remember this function, we're going to write 1 over 2 minus sine x. And then we're going to evaluate that, right? We're going to put g of x in there. Well, what is g of x? G of x is 0. So we're going to evaluate this at x equals 0. And so this is going to be 1 over 2 minus sine of 0, which is 0. And so that's going to be 1/2. And so what did we find? We found g prime of 1. Okay, so here's the same type of problem, but it's stated a little bit differently. it's also you haven't been given all the information that you need for this. So first thing we're going to do is verify that f has an inverse. Then we're going to use function f and the given real number to find f inverse of a. So one thing that we do notice is that we're trying to find f inverse of a, 2. But we don't know what that equals. And so if you'll recall, that means that f of something is equal to 2 if we rewrite it backwards. So we really need to find this value x because that's what we're going to be evaluating. So what we want to do is we want to set the function equal to 2. And I didn't write that right, x to the third. So then I subtract the 2 over, and I have 0 equals x to the third plus 2x minus 3. Now, this is not factorable. This does not allow us to find it using an algebraic method that I'm aware of. I mean, you could kind of guess, right? Because if you let x equal 1, then you would have 1 plus 2 minus 3. But most likely you would put this in a calculator, and you would put this in y1 and you put this in y2, and you would see where they intersect, which is basically the x-axis. So we have found x. This means that f of 1 is equal to 2. Okay, and so what we want to do then is find the derivative of this function, and that would be 3x squared plus 2x, right? And then we want to write this over 3x squared plus 2x. We want to evaluate it at x equals 1, and we would end up with 1/5. So the only thing we're really adding to this is that we are setting it equal to 2, the given value here, and then evaluating it with the value that we find. One final example. Once again, g of x is equal to the inverse of f. We're asked to find g of a and g prime, so the derivative of g at a. So the derivative of the inverse, and a is 1. F of x is the square root of 3x plus 1. All right, so once again, we know that this is g of 1 equals some value. We need that value. So we're going to set our function equal to 1 and solve. So 1 equals the square root of 3x plus 1. We're going to square both sides. So 1 equals 3x plus 1. We're going to subtract 1, and 3x is 0. So guess what? X is 0. All right, the next thing we want to do is we want to take the derivative of f. Right, so I'm just going to rewrite it. 3x plus 1 to the 1/2 power. F prime of x is 1/2 times 3x plus 1 to the negative 1/2 times 3. And if I rewrite that, that's going to be 3 over 2 square root of 3x plus 1. Okay, now to find the derivative of the inverse, I'm going to do 1 over 3 over 2 square root of 3x plus 1, right? And I want to evaluate that at x equals 0. Right, so when you divide by a fraction, you just multiply by its reciprocal. So I've got 2 times the square root of 0 plus 1 over 3, which is 2/3. So what did we find? Well, we found g prime of a, which is 1, and that was 2/3. Over here, we found g of 0 equals 1. I think I have that backwards, which is easy to do with inverses, don't you think? It's kind of easy to get that backwards. All right, so what we found was we set f of x was 1. So we said f of, I have it right, f of 0 is 1. So g of 1 is 0. And that's what we were finding here, was the g of 1. So here's g of 1. And then we also found the derivative, and that was 2/3. So we've answered the question. All right. So we'll have quite a few of these to work in class, so we can really get this down. But as you can see, mostly it's just finding the value that we need to plug in, taking the derivative of the function, plugging that value in, and getting the derivative. So kind of interesting. And we'll do some more of these in class. So I'll see you then.